IC engine, an acronym for an internal combustion engine in which ignition and combustion of fuel take place inside the engine. It works on the principle that the charge is ignited inside a combustion chamber under very high pressure. The first commercially successful IC engine was created by Etienne Lenoir around 1860, and the first modern IC engine, known as the Otto engine, was created in 1876 by Nicolas Otto. The term internal combustion engine usually refers to an engine in which combustion is intermittent, such as the more familiar 2-stroke and 4-stroke piston engines, along with variants, such as the 6-stroke piston engine and the Wankel rotary engine. Now let's understand the different parts of IC engine. Cylinder block. It is the structure which contains the cylinders and other components. Cylinder. It's a chamber where fuel is combusted and power is generated. Cylinder head. It sits above the cylinders and forms the roof of the combustion chamber. Piston is a moving part of the combustion chamber. It is responsible for converting the energy released during the combustion process into mechanical work. Piston rings is a metallic split ring that is attached to the outer diameter of a piston in an IC engine or steam engine. Piston rings are used for sealing the combustion chamber so that there is minimal loss of gases to the crankcase. Connecting rod connects the piston to the crankshaft. The reciprocating motion of the piston is converted into rotary motion of the crankshaft. Upper end of the connecting rod is called small end, which carries the piston by means of a floating pin called piston pin or gudgeon pin. The lower end is called big end of the connecting rod, which connects the crankshaft through the crank pin. Crankshaft is a mechanical component used by a piston engine to convert the reciprocating motion into rotational motion. Crankcase. This is the main housing at the bottom of the engine, providing support for the cylinder and crankshaft bearings. Valves. The engine valve's primary function is to allow air into and out of the cylinder. Crank pin connects the crankshaft to the connecting rod for each cylinder. Intake and exhaust ports. These ports are passages cast in the cylinder head, leading from the manifolds to the respective valves. For petrol engine, spark plug is used to ignite the compressed air-fuel mixture. For diesel engine, injector is usually used in compression ignition engine. It sprays the fuel into combustion chamber at the end of compression stroke. It is fitted on cylinder head. Now let's take a look at working principle of 4-stroke petrol engine. The petrol engine works on the principle of Otto cycle, also known as constant volume cycle. The spark plug fitted at the top of the cover initiates the ignition of the petrol. In 4-stroke engine, all the events, that is intake, compression, power, and exhaust, are completed in 2 revolutions of crankshaft. They are as follows. Intake stroke. The stroke begins when the piston is at TDC, top dead center. The piston moves downward, the inlet valve opens. A mixture of petrol and air vapors, mixed proportionally by the carburetor, enters the cylinder and fills the space in the cylinder. The piston reaches its lowest position known as BDC, bottom dead center. Compression stroke. The piston moves up after the intake stroke, the inlet valve closes when the piston moves upward, the exhaust valve also remains closed. The piston compresses the fuel-air mixture by pushing it upward into clearance space at the top of the cylinder. The pressure and temperature mixture increased during compression. Power stroke. The fuel-air mixture at high pressure and temperature is ignited by a spark. The spark ignites the fuel-air mixture. This burning increases the pressure and temperature of the gases further. The gases expand, producing an explosive force pushing the piston down at high acceleration. Then the linear movement of the piston is converted into rotary motion of the crankshaft. Exhaust stroke. Piston reaches the bottom center at the end of the power stroke. The exhaust valve open, the burnt gases escape at greater speed. The piston moves up from bottom center and push out the remaining burnt gases inside the cylinder. At the end of the exhaust stroke, the exhaust valve closes, and the cycle is repeated. For every 4-stroke of the piston, the crankshaft rotates 2 revolutions. Working of a 4-stroke diesel engine. The basic construction of a 4-stroke diesel engine is same as that of 4-stroke petrol engine. except instead of spark plug, a fuel injector is mounted in its place. A fuel pump supplies the fuel oil to the injector at higher pressure. It works on diesel cycle or constant pressure cycle. Intake stroke. In intake stroke, the piston moves down, the inlet valve is open, that allows air to enter the cylinder and fills the space. Then the piston reaches the bottom center and again starts moving up. Compression stroke. The piston starts moving up, the inlet valve is closed, then the air is compressed. The pressure and temperature of the air increase due to compression. Just before the piston reaching top dead, diesel fuel is sprayed inside the cylinder. The fuel is sprayed by means of a fuel injector at a very high pressure, overcoming the pressure of the compressed air. The fuel gets mixed up with air and it contains oxygen. Since the fuel is a hydrocarbon, the temperature of compressed air is sufficient to initiate the combustion, and the fuel is burnt. Power stroke. The piston moves from top dead center to bottom dead center. The heat released by combustion increases the pressure and temperature of the air further. The maximum pressure and temperature of the burnt gases act on the top of the piston and forces the piston to move last, accelerates the piston downwards. Just before the piston reaches the bottom dead center, the exhaust valve opens. Exhaust stroke. The piston reaches the bottom dead center and starts moving up. The burnt gases are being pushed out by the piston and escapes through exhaust valve. Before the piston reaches top dead center, the inlet valve is opened, and the cycle is repeated. Working of a two-stroke petrol engine. The two-stroke engine requires one revolution of crankshaft or two strokes of the piston to complete the cycle of events. Two-stroke petrol engine also work on the principle of working of the Otto cycle. In first stroke, the piston is at its bottom dead center position. During this stroke, the piston moves upwards from bottom dead center to top dead center. It closes the transfer port and the exhaust port. The charged air and petrol mixture, which is already there in the cylinder, is compressed. Due to upward movement of the piston, a partial vacuum is created in the crankcase and a fresh charge is drawn into the crankcase through the uncovered inlet port. At the end of this stroke, the piston reaches the top dead center position. In second stroke, the compressed charge is ignited in the combustion chamber by means of an electric spark produced by the spark plug, slightly before the completion of the compression stroke. Due to combustion, piston is moved downward direction. During this stroke, the inlet part is covered by the piston and the fresh charge is compressed in the crankcase. Further downward movement of the piston uncovers the exhaust port and then the transfer port. The expanded gases start escaping through the exhaust port, and at the same time fresh charge, which already compressed in the crankcase, is forced into the cylinder through the transfer port. The charge strikes the deflector on the piston crown, rises to the top of the cylinder and pushes out most of exhaust gases. And the cycle of events is then repeated. Two-stroke diesel engine. It works the same as that of the petrol engine, but it injects diesel at end of compression stroke. When the piston is at the top of its travel, the cylinder contains a charge of highly compressed air. Diesel fuel is sprayed into the cylinder by the injector and immediately ignites because of the heat and pressure inside the cylinder. The pressure created by the combustion of the fuel drives the piston downward. This is the power stroke. As the piston nears the bottom of its stroke, all of the exhaust valves open, and the exhaust gases rush out of the cylinder, relieving the pressure. As the piston bottoms out, it uncovers the air intake ports. Pressurized air fills the cylinder, forcing out the remaining of the exhaust gases. The exhaust valves close and the piston starts traveling back upward, recovering the intake ports and compressing the fresh charge of air. This is the compression stroke. As the piston nears the top of the cylinder, the cycle repeats. Now let's look at the advantages and disadvantages of four-stroke engine over two-stroke engine. The power developed in a two-stroke is double that of a four-stroke engine. Due to shortening of effective stroke length of the piston, and due to the fact that the engine is to operate the scavenging pump, the actual power developed in a two-stroke, instead of being double, is 1.7 times that of a four-stroke engine. The turning effort on the crankshaft of a two-stroke is more uniform than that of a 4-stroke. Due to uniformity in turbine effort, the weight of flywheel is necessary in case of a 2-stroke. It is about 0.40 times the weight of the flywheel used in a 4-stroke engine. A 2-stroke engine being lighter and smaller, and it take less space than that of a 4-stroke engine for the same power due to reduced cylinder dimensions. The cylinder temperature in 2-stroke being higher than that of a 4-stroke engine. The gear arrangement necessary for reversing a 2-stroke engine is more simple than that of a 4-stroke engine. The absence of exhaust valve in case of a 2-stroke engine is of great advantages in large engines. Disadvantages. Due to higher cylinder temperature, there is a risk of fire in case of failure in cooling system in a 2-stroke engine. Lubricating oil consumption is more in case of 2-stroke engine. Thermal efficiency of a 2-stroke engine is less than that of a 4-stroke engine owing to fuel losses during scavenging. In the 2-stroke engine, the technology used leads to more fuel consumption as it expels the fuel even before it is processed and burned. In the 4-stroke engines, there are dedicated strokes for exhaust, consumption, and power. The crossover or ratio for fuel to exhaust is significantly reduced for this reason. For the same number of revolutions of the crankshaft, the valve gear of a 2-stroke engine operates at twice the speed required in a 4-stroke engine. This causes more wear and tear of the moving parts and greater noise during running. So that's it, thanks for watching. If you want to learn more on engines, check out these videos.